I'm just about to start. Good morning, everyone. Welcome to today's webinar, Manufacturers Roundtable, Heat Pump for Pools and Spa, 17 July 2024. I'm Vidisha Mupnar, Project Analyst with New Buildings Institute. And today's webinar has been developed in collaboration with CEDA, California Energy Design Assistance. And we have Sean Williams with us, who will brief us about the CEDA program. Over to you, Sean.
Hello, all. Thank you for allowing me a few moments to speak with you in regards to the California Energy Design Assistance Program, also known as CEDA. My name is Sean Williams, and I do work
Sean,
for
could you please slide?
Oh, there you go. My name is Sean Williams. I do work for Willdan, and I do perform outreach within the CEDA program. So any questions or all things related to CEDA, I will definitely be your contact to help address any questions. So what is CEDA? The California Energy Design Assistance Program. It is the only statewide utility incentive program for new construction and major renovations projects. The CEDA program does serve to promote electrification and decarbonization within new building construction as well as major renovations alike. CEDA does work in collaboration with project teams to reduce energy demand consumption as well as carbon emissions. And through the program, we do serve commercial, public, high-rise, multifamily, industrial, agricultural projects located in the Pacific Gas and Electric, Southern California Edison, SoCal Gas, and San Diego Gas and Electric service areas. Okay, next one. Okay, so why participate in CEDA? $1 million question, right? So a couple of reasons here. Through the program, you will receive a complimentary decarbonization analysis tailored to specific project goals to help identify the most effective measures to implement. Through the program, you'll also gain analysis of energy costs and paybacks, receive financial incentives to help offset the cost of decarbonization measures, and then also, last but not least, demonstrate commitment to high-performance building practices and design. Okay. So let's talk a little bit about the incentives here. So through the program, there is a flat $2,800 design team incentive that is offered per project as a thank you for participation. In addition to that, we also include and offer a measure package incentive. Now, this is the primary reason that design teams would, of course, and owners, developers alike would choose to opt in to participate in a program such. And the measure package incentive is based on the project measure package the design team chooses for implementation. So the actual final incentive amount is subjective based on what is going into the project from an energy efficiency standpoint and what the team might be willing to consider, which we will cover those measures with the team. Okay. So just a quick moment here talking about the high performance measures section of the program. So CEDA does aim to exceed California's decarbonization standards by identifying high performance measures and providing educational opportunities to explore use cases and best practices. This not only advances the market, but also qualifies participants through enhanced incentives through our program. So a list of current high performance measures can be found on our website, but also through the program, we'll cover some of the high performance measures with the team. Okay, and if you have a project to discuss or you'd like any more information in regards to the program, you can either scan the QR code directly on your screen to enroll a project straight away, or my contact info is right here. My email, you can shoot me over an email, and that is just swilliams@willdan. So we love the opportunity to talk to anybody, any and all members about their projects they're currently working on and provide assistance. Thank you.
Thank you for that, Sean. Moving back to the webinar topics. Today we'll be discussing a few things on heat pumps and for the pools and spa. Why do we need to embrace heat pumps for warming up your pools and spa? What are some of the products that are available in the market? Is there a challenge or barrier to the market adoption of these products? And what does the market scope potential look like in the near future? We're talking about these and a lot more through case studies, retrofit feasibility studies, product landscape, and I'll touch upon affordability, cost and energy savings, energy efficiency, and design implementation. And for this very constructive discussion, I have an incredible team of panelists today for the webinar. I'm pleased to welcome Dylan Anderson from Redwood Energy. Dylan is an electrification analyst. He is an environmental science graduate from Humboldt State with a focus on climate and energy. As an electrification analyst, he compiles energy analysis reports, affordable housing documentation, and develops novel research about electrification technologies. Following Dylan, we have Eric. Eric Rocker is the Senior Product Manager, Pool Heating, RAPAC, a division of Rain. Eric has a bachelor's in business administration from University of Michigan, and he has over 5 years of industry experience. Eric is also joined by his colleague Parimal today, who is a senior engineer at Rain for heat pumps. We then have Don Tuck. Don is a Western States Territory Manager at Aquacol Autopilot. Prior to joining Team Honor at Aquacol, Don has a long-standing career of 30 years in the renewable energy industries and swimming pools and spa. Our final panelist is Morgan Heater. Morgan is a senior mechanical engineer at Ecoto. Morgan has been working in the field of high-efficiency system design buildings since 2003. He has designed mechanical systems for residential buildings, large commercials, education facilities, and of course, pools. I'm pleased to invite you all for the webinar today, and I'm really glad to have you all on board. Before we move on to the presentation, a quick reminder, for the Q&A, please use the chat box. You can put in your questions. We'll take them up during the panel discussion. And the panelists will also respond to your questions in the meantime, once their presentations are over. So we'll start with the first presentation today, and we have Dylan talking about affordability and some insights from the case study. Over to you, Dylan.
Thank you, Vidisha. So, as Vidisha said, my name is Dylan Anderson. I've been working with Redwood Energy for 5 years. Today, I'm just going to go over what I'm going to walk you through today. Some of these topics might be familiar to you. Some of these topics might be new to you, but it's often helpful to start from basics so that we all have the same understanding of things like what is a heat pump? What's the difference between a heat pump and a heat pump water heater and a heat pump pool heater? And I'm also going to show a couple of great product options in the residential side. In hot tubs, there's a pretty wide market for heat pumps that are designed specifically for use in hot tubs. And then some of the commercial options that we've been able to find through Redwood Energy's research and advisement of clients. And then I'm going to talk briefly about a case study where a heat pump pool heater was used by an early adopter to retrofit an existing pool setup. And then I'm also going to talk about the affordability argument for heat pumps, which is always a fun conversation because usually the conversation ends in, yay, you get to save money, or it costs about the same as gas, and now you're off of gas, and that's what we want to see in the world. Just a quick mention, I work for Redwood Energy. Half of our business, we advise affordable housing developers, mostly in the multifamily sector, to reduce their energy usage. And we've also have a creative way of getting around the tenant owner situation with that, where we're able to reduce the tenant bills, and then that also gives a little bit more revenue for the owner without impacting the tenant. And that's a really great way to get efficiency upgrades and solar in particular installed at multifamily apartments. We kind of have been like trying to spearhead the electrification movement and get it, squarely on the idea that we don't really need to use natural gas anymore. Like the switch is right there. We can flip it. We're ready to make the transition. And here's a couple of 6 examples of our guides that we've written, and we have more research available on our website. We also have a watt diet calculator, which is used to size your electrical service. And we're working on a multifamily version of that. That one only works for single family, but you can still use it if you have like a condo or like one unit that you want to retrofit just that unit. It'll still work for one multifamily unit. So what is a heat pump? Again, this may be a conversation that's familiar to you, but it's good to talk about it because there's all kinds of heat pumps. On the top left, you can see an example of a mini split. This is probably what most people are familiar with a heat pump. It has an outdoor uh, coil, which handles, in this case, because it's a heat pump, it does condensing and evaporating, which basically just means it puts heat out into the world, or it takes heat from the world and moves it inside. So the magic of heat pumps is that we're able to use a little bit of electricity to start the ball rolling inside of this closed mechanical system, this closed refrigerant loop, which pushes heat in one direction or the other, depending, you know, I couldn't figure out how to get the arrows to turn around on this diagram, but if they could, you would be able to just completely mirror image this and have the condenser be on the left and the evaporator be on the right. And so just with that, that's pretty cool, right? Because now we have a car that can go in forward and it can also go in reverse. That's pretty important. Um, but part of the magic of heat pumps is that they're able to use a little bit of electricity to push a lot of heat. And pushing a lot of heat means that we're getting efficiencies that are actually above 100%, which is never a thing that you should hear outside of heat pumps and outside of the refrigeration cycle, because it's, you know, without getting too deep into the thermodynamics of it, most things in the world are not 100% efficient. Most things don't like get close to 100% efficient, but they can never get there. But for heat pumps, we're not working in that same space because we're pushing the refrigerant through the pipes in the system. And by pushing it, the refrigerant pulls heat from the condenser or yeah, pulls heat from the evaporator, which can also be the condenser. And by doing this, we're able to use a little bit of electricity to make a lot of heat. And so you can see that there's all kinds of examples. We have modern chillers are almost always heat pumps because it just makes sense to in most cases. On the bottom right, you can see an example of a heat pump water heater. Um, that is not what we're talking about, but it's very related to how heat pump pool heaters work. Because essentially, instead of taking heat from outside air and putting it into inside air, we're just putting the heat into the water. And in doing that, what we're going to see is a typical efficiency is somewhere between 300 and 400%. And like many of the products in the heat pump pool heating space and the spa space are hitting 500%, 600%. Not all the time. It also depends. Like that efficiency depends seasonally on what temperature the outdoor area is and what temperature your water is. On the bottom left, you can see an example of a heat pump pool heater. Um, and yeah, this is just a good example of this product has really big um, inlets and outlets for the water, and its job is just fully focused on taking heat from the outdoor air and putting it into the water. And when I say taking heat from the outdoor air, you're probably thinking, well, like, how does this work in cold climates? And that's a good question. And it's a question that's been answered. Um, there's technology called inverters, which is really important in cold climates because it's able to make the heat pump run at those colder temperatures, and it kind of expands the temperature range. Um, and it makes them quite a bit more efficient too, because it has a lot to do with how the compressor actually works. It's kind of like a transmission in your car. It changes the gears on the compressor. So, enough car analogies. One thing I want to talk about is heat pump water heaters. I want to just get it out of the way that generally you're not going to use a heat pump water heater for a pool. You could use a heat pump water heater for a hot tub, but only very specific ones. And that would be something that you would need like a full scope engineer to make sure that you're actually mixing down the water correctly. That's a whole nother topic. Um, but I just want to put it out there that these are an option for some edge cases. You could use them as like a booster heater if you had a commercial project that needed, just a little bit more oomph to get it over the edge. Like maybe you're in a very cold climate and you have really cold hot water temperatures. It might make sense then to use a Sanco unit on the right hand side here, which is a CO2 heat pump that has that inverter. And it also just works really well down to -20. Um, and by pairing that, you might be able to push a little bit harder. But generally, the issue is that these are going to put out much too hot of water for even a hot tub. You're not going to want a hot tub that's 120 degrees. That's just ridiculous. So if you were to do that, you would need to bring a plumbing engineer on to make sure that everything's situated and we have balanced hot water so that you're actually getting temperatures that are safe for people to either swim in. You could use it for a commercial pool, but it's most likely going to be something that you're going to see with the hot tub. Now I want to talk about residential grade heat pump pool heaters. This is an area where we have a ton of options right now in the market. Um, and within these options, there's some products that have inverters and there's some that don't. Our general finding is that the inverter compressors are going to be what you want if you have very cold outdoor temperatures. Like you can see the lowest that we're getting right now with a heat pump pool heater is 25-degree outdoor air, and that is really pushing it on a lot of these units. So again, that's a situation where you would probably want something to stage it like a Sanco CO2 heat pump. But for most folks, we're not necessarily, especially in a pool, we might close down the pool in the winter. Um, we're unlikely to, we're often unlikely to close down hot tubs in the winter, but in a lot of cases in colder climates, it just doesn't make a ton of sense for folks to keep the pool open all year. So then these products probably make a lot more sense for you. Um, moving on to hot tub heat pumps. This is another area where we have a ton of diversity in product range, and we're seeing really high COPs. We're seeing, 6.3. That's a crazy high COP, but you'll notice, that unit uses only down to 42-degree Fahrenheit outdoor air. This is an area where inverters are also very important. On the far right here, we have the Arctic brand. Northern Lights is a specific model, and those are made in Canada, and they go down to 20 degrees outdoor air, and they output water at 104 Fahrenheit. So now you're getting, hot tub spa temperatures as opposed to for the residential grade heat pumps. for pools, they're mostly going to output water at 80 degrees or, perhaps a little bit higher as part of their set point band. For the commercial grade heat pump water heaters, this is still a growing market. There are a couple options that are like the AquaCal icebreaker. That's sorry that says icebreaker. This is supposed to say Great Big Bopper or GBB. This unit is pretty much the only one on the market that is going to work for a larger pool. And as we get into very large pools, you're going to want to go towards a design build system right now, which is where you would go to a manufacturer like Link. On the far right here, you can see Link's Aegis A CO2 based heat pump. CO2 is a good refrigerant for cold climates, goes down to -4, which is really great. But you need to go with a design build solution if you get beyond the too far beyond the reasonable capacity of essentially the Great Big Bopper is the option that's on the market for large community pools, or if you have a college campus that has a pool, something like that that's Olympic size or in that range. That's where you start getting into like this is going to be a really big project, but it's going to be worth doing. We've seen some worries about that, but the cost versus just replacing gas is not actually that much worse. It's on the order of 1.5 times. So it's worth looking into, even if you have like a large gas system, and it's worth looking into now rather than having to deal with, oh, my gas boiler broke, I need to replace my heat pump. This is just an example of a large commercial system. This is in Tamarack, New York, so kind of like just north of the Catskills. This indoor pool also goes out to outdoor, and then they have a lap pool. They have a like typical like hangout swim pool, and then they also have several hot tubs that they all run off of a cascade system, which is where you take an air source heat pump, which is essentially the same as a typical one that I've been showing, and pair it with a water source heat pump so that you're able to push a little bit further, kind of the same thing that I was talking about with using the stand-ins as a booster. And here's my last slide. Heat pump affordability is really good. Depends on your rates more than anything. Even in California, where we have cheap natural gas and high electricity rates, it still costs out to replace a gas pool heater with a heat pump. Save 12% year over year. And for most of the country, you're going to be saving a lot of money by switching to a heat pump, upwards of 70%. And those are my slides. Thank you.
Thank you, Dylan. Thank you for touching upon the topics of affordability. And we have our next presentation, Eric Ruckel from REAM. And before Eric comes up with his presentation, just a quick note. We do have a question on the size, how to choose the right size for the heat pumps with respect to the size of the pool. And we will follow up on this question very soon because we do have some of the presentations coming up that will cover this topic. So over to you, Eric.
Thank you very much. Can everybody see my screen okay?
Yes.
Great, thank you very much. So thank you. I am Eric Roquel. I'm the Senior Product Manager for pool heating and really now pool cooling as the industry is moving towards at RAPAC, which is a division of REAM. And REAM is a global organization. So we have other business divisions and offices throughout the world, including the Netherlands, China, several locations, Australia as well. And so really the RAPAC division was acquired by REAM, and RAPAC started as a boiler company and then moved into pool heating. And so over the years, we have evolved to have a pretty broad line for pool heating products. So we do everything from, gas pool heating products of a wide variety of BTU ranges, heating capacities, also electric resistance heating. So where we're using heating elements to heat the water, as well as heat pumps. And you can see from the image here that we're doing side discharge heat pumps at your left, which, Dylan had referred to really as a spa heat pump, if you will, or a hot tub heat pump, and our Crosswind V, a larger volume heat pump pool heater. And really overall, Rheem as a company is really focused on what we have as our greater degree of good program. So that is really a way of looking at efficiency and energy and carbon reduction throughout our company, and that relates to everything from the products themselves being efficient and low carbon or zero carbon emissions, all the way through how we manage our factories and our production and our business practices to ensure that we're zero waste to landfill, that we are instrumental in getting industry up to speed on how to be more energy efficient and low carbon emission oriented, if you will. So really it is a company culture thing that we've embraced over the last few years that is sort of a very holistic approach for us, again, from product all the way through all our operations and business practices. So, we talk about sustainability, as also being a wonderful business initiative, which always, makes the check writers and cashers happy in the industry. But, we know that customers, more and more every day want to buy sustainable products. So we're really doing our best to produce those products and obviously to communicate those benefits to the world at large to transition our industry. So what we found is that really, we need to really better highlight what our sustainable options are. So we have what we call our sustainability standout products, of which heat pumps are a large part of that, and try to identify those for our customers. We're working on all the other things that many other companies are working on, right? Paperless, recyclable packaging, all these great things. So we as a company, again, are just very oriented on how we can do better and be more energy efficient. So we'll talk a little bit about our Crosswind. This is our latest introduction. This came out late last year, heat pump pool heater, and we do these in capacities from 90,000 BTUs per hour up to 140,000 BTUs per hour. And just to kind of correct a little something that Dylan said, and I have no doubt as an engineer, he's much smarter than a product manager who came from a marketing background. But I just wanted to say that, as an industry, and I think Dom would agree, we really don't necessarily differentiate between something that's designed to heat a spa or a pool in the sense of temperature capabilities. So our Crosswind side discharge, our lower capacity heat pumps will heat pools as well as our large ones and heat spas. So all of these have temperature range settings that can go up to 104 degrees to heat a spa. It's really more about the body of water that you're trying to heat, how many gallons you're trying to heat, and then deciding or determining how many BTUs or kilowatts you need to achieve that desired set temp. So back to the Crosswind itself, some of the innovation that we're bringing to the industry as far as heat pump technology and really pool heating technology in general is having smart controls on board. So traditionally, when you bought pool heating equipment, you would buy your heater, you buy your pump, you buy your filter, and then you would buy a control unit that would allow these components to speak to each other for the purposes of scheduling and set temps and whatnot. So what we've done is we've built sort of a small pool controller within each of our heaters. So even as I mentioned on our gas line, as well as our Crosswind V here, we actually have a small, sort of a controller for the pool that will allow most pool users, those that don't have, booster pumps for waterfalls and maybe, some other really sophisticated additional equipment. But if you're just a pump and filter and lights kind of pool, which is what most residential settings would have, you're able to control that without the addition of another controller, an external control, which is a big savings to our customer. But the other thing that we've built into this is we've got algorithms in place that are going to allow you to pair this heat pump pool heater with a gas pool heating system or with a solar rooftop solar pool heating system. And I don't mean photovoltaic, but actually tubes on the roof, right, that are heated up and heat the water for use in your pool. But our Crosswind unit will work with those other partner pool heaters, if you will, to determine where the best energy resource is at that time of day relative to energy costs. And so this can be programmed to have your pool manage where it is getting its heat source from, whether it's coming from the rooftop solar or whether your heat pump needs to kick in to provide additional heat. The Crosswind also is a heat cool unit, I'll mention, and we do have heat only units, but heat cool, and I'm sure Don will attest to this as well, is really a growing part of the world, or of the industry as the world gets hotter, and in our key regions like Arizona, Texas, Florida, right? Pools get pretty hot even without the assistance of a heater. So really what we're looking at now is customers want to cool their pools. They want to cool the water. So this is not something that is going to be as easily accomplished. You can't do that with a gas pool heater, but with heat pumps, we can hit the reversing valve, right? As Dylan, I think, had mentioned earlier, we can switch this around and we can turn this into a cooling unit. Most heat cool units today, because they are primarily configured to do the heating function as a primary function, the cooling capacity usually is about a third of what the heating capacity is going to be. But of course, there are now in the industry, you're starting to see chillers, which are 100% focused on cooling the pool, and all the distribution circuits and compressor, everything is set up for primary cooling function. This scheduling and this control of the heater on our Crosswind product can also be done through your phone. So you can certainly have set, let's say, scenarios, if you will. So at certain times of the day, you can manage how fast your pump speed operates, when your heater goes on, what those set temps are for various times of the day, and even to choose energy efficient times or more cost efficient times to run your pool heater. We also have a little more robust line in our professional series heat pump, which was shown a little bit earlier. When you get into this line of products, we're talking about some stainless steel and some other things to make the cabinet itself more robust. But additionally, we're moving into larger heating capacities, and we're looking at three-phase power options as well. So for commercial environment, this is a very viable product. And as mentioned, these units can also be cascaded in order to achieve higher BTU, higher kilowatt output as a whole. Our Rheem Australia division. Now, Australia is a country that's been challenged, right, for many years, much earlier than us, with energy efficiency initiatives, due to the heat down there and the limited water and all kinds of other things. So they are actually ahead of our other divisions at Rheem with heat pumps, and so now we are moving into that space as well, as could be expected. But even today, with our Rheem division in Australia, we can provide heat pumps up to 1.5 million BTUs of heating capacity. So, this Rheem as a company as a whole, we've got air and water heating solutions through heat pumps, and that's both pool water and domestic hot water as well. So we're in full mode with heat pumps. One thing that's important for us, as I mentioned earlier, is to make sure that the industry itself and the pool professionals are trained up, because there's a lot of myths out there about, heat pumps don't work in California, heat pumps don't work in Michigan. I know nothing about these things. So the air conditioning industry is up to speed, but in the pool heating industry, it's primarily gas or electric heating that's been, the major player so far. So part of our mission in introducing these products and transitioning the world over to heat pump is to make sure that we've got a good training program to train our service base on how to install and service heat pump pool heaters. So what we've seen in the industry as challenges in the move from gas to heat pump, a few different things. One is the space requirement. So the red heater on the left is our Avia gas pool heater, and that particular one is a 400,000 BTU per hour heater. The heat pumps on the right are three 140,000 BTU heat pump pool heaters, right? So that's going to give you 420,000 BTUs. So to have the equivalent BTUs per hour output, you would need to have three of these running in series. So if you were going to do that and you want to achieve the same temp rise as you might with a 400,000 BTU gas pool heater, you're going to need to install three. So the time to heat, again, is the same thing here, right? So if you have a 140,000 BTU standalone single heat pump pool heater and you've replaced a 400,000 BTU gas pool heater, right, your time to heat to the desired set temp is going to be longer. these heat pumps are going to be running more during the day than your gas pool heater was. So when you think about those things, your equipment and your installation costs can often be higher for heat pumps than they are for gas units. But with that said, right, heat pumps are really water and electricity, whereas a gas installation is going to be water, electricity, and gas. So, but it is something to consider, especially because sometimes, you need to upgrade your breaker panel as well in the process of moving from a gas pool heater to a heat pump. Another challenge we have is cold climate operation. So as was mentioned earlier, your heat pump pool heater and your heat pump efficiency in general is going to go down when you're outside of your ideal temperature and ambient temp and humidity range. So one of the challenges is to figure out how to make heat pumps more efficient at these very low ambient temp operating ranges. Of course, inverter technology can definitely assist in that. And these are, things that all the companies in the space are actively pursuing for both air and water heating opportunities. So some of the things we can do to mitigate some of these issues, right? Some of these challenges that we have with heat pumps. So as mentioned, once people make the switch, right, you make that initial investment in heat pump, the product longevity of a heat pump is better than that of a gas pool heater, and your long-term operating costs over time are going to be lower than gas-fired pool heaters. Obviously, there are factors that can adjust that, and that is how much do you pay for gas in your region, how much do you pay for electricity in your region, but overall, over time, the heat pump will ultimately be more cost-effective as a solution. One of the challenges with all pools and pool heating is heat loss, right? And because the heat pump is going to have a longer recovery time to get back to your set temp, one of the things you can do is ensure that you've got either a standard or even a solar pool cover installed on your pool. And in California, that's going to be is mandatory. So that's coming. We've got solar pool heater integration. I touched upon this earlier. So if you're going to use the solar tubes that carry water up to the top of your roof for heating by the sun, you can use that as standalone, but certainly to make a heat pump more efficient, you can work with an integrated solar heat pump, or sorry, solar pool heater to achieve better performance out of your heat pump. One of the other ones that is been kind of challenging, because if you see a lot of the regulations, they're really going towards zero carbon emissions product, right, which effectively bans gas. However, in places that still do allow gas, what we found is that a hybrid gas and heat pump solution is ultimately more efficient than just using a heat pump alone. And this was something we experienced in the Netherlands as we were working with the government on initiatives around water and space heating, domestic hot water and space heating, where the government had mandated the elimination of gas pool heating. And so what we were able to demonstrate is that when properly controlled with system optimized controls, you can actually have a heat pump and a gas pool heater operate overall more efficiently than just a heat pump on its own. So we're learning a lot. Obviously, regulations are pushing the industry that way, and we fully embrace that. But overall, I think that it's really exciting to see all this change. And I can tell you with confidence that if you took a look at Raypak Rheem's product roadmap, that probably 80% of it is occupied with addressing regulatory space and upcoming regulatory changes. So we're full on, we're providing more solutions, and we're happy to be a resource should you have any questions. Thank you for listening.
Thank you for that insightful presentation, Eric. We do have follow-up questions on that, which I'm going to save for the panel discussion. I also had the same question regarding carbon footprint, but I'm going to save this for the panel discussion, and we'll move forward to the next presentation. While Don gets his slides ready, I just want to give a brief about what Don has done for us. So he's going to get into decarbonization, some of the aquaculture products, and he's going to clear the confusion about sizing, how to choose the right size for your pools. Thank you, Don, and I'm passing it over to you.
All right. Can you see my screen?
Yes.
All right. Am I in the right mode? Let me check.
Would you want to put this in the presentation mode?
Yes, I'm going to do that right now if I can get there. Hang on one second. It was there. Now it left. There we go. How's that? Can you see that presentation mode?
Yes.
Okay, so again, my name is Don Touch. I'm the Western Territory Manager for AquaCal Autopilot. And I'm just going to continue the conversations and elaborate a little bit more on what Dylan and Eric had to say. Great information. And I'm going to talk about how it's easily to comply with all the new regulations, the growing decarbonization regulations, and still enjoying, a hot pool and spa, and how to do it affordably. So there's this myth: heat pumps don't work. Heat pumps don't work in California. There's no humidity. It's too hot. It's too cold. It costs too much to run. Well, that is what they say. However, the mythbuster is AquaCal heat pumps do work in California. So I get a lot of these frequently asked questions, and these are just like the top 6. Do heat pumps really work? And I could say confidently they do work. Do they need humidity? Well, again, that's a myth. Humidity plays a small factor in it, but like your air conditioner or your refrigerator doesn't need humidity, these don't need humidity as well. How are they installed? It's basically 2-inch plumbing in and out, and a electrical hookup, usually a 50 amp breaker or 60 amp breaker, depending on the size of the unit. And are heat pumps electric heaters? They're not electric heaters. What they are they're a heat pump that uses electricity just to run the compressor, and then a small low voltage fan that goes inside. Clearances that are needed, typically 2 feet all the way around, and then like 5 feet clear on the top. And if the heat pump needs service, we have a full line of service centers all over the United States, actually all over the world, to repair these. All of our heat pumps are made in Florida, and we run our own service company in Florida. However, in California or other areas, you simply call the number on our heat pump and we will dispatch a service center to take care of it for you. So really, what do you want to do? You want to eliminate your high gas bills, you want to extend your swim season, and you want to increase the efficiency of variable speed pool pump, right? So how are you going to do that? Well, with AquaCal heat pumps, you can enjoy your pool or spa affordably, right? So I'm going to talk a little bit about the future of energy and kind of where this whole decarbonization electrification is going as far as the pool industry goes. So as Dylan said, the switch is on. I'm based out of California. California is kind of leading the way. So whether it's Edison or DWP or, all the different utilities, they're all making the switch, and it's here. So touch a little bit on the regulations. So it started in 2018, where California passed a law, the Senate Bill 100, requiring to derive 100% of its power from zero carbon energy. They wanted to do it by 2045, and they wanted to do a bold path, right? That was followed up by Assembly Bill 3232, requiring California Energy Commission to assess by January 21 how to get these levels in state buildings down by 40% below the 1990 levels, and do that by 2030. And then the more recently, Senate Bill 1477 provided $50 million in annual incentives through 2023 to jumpstart the market development for low emission buildings. So whether it's 100, 3232, or 1477, everything's charting a path for lower emissions, more affordable and healthier buildings for California. So 100% renewable energy means cleaner and better future for our children. And to accomplish this, public policy leaders believe the state must eliminate all fossil fuels by 2050. So the bottom line is these statutes will require the electrification of California to be supported entirely by using generated by solar, wind, geothermal, or hydroelectric power. So a number of cities have taken up the mantle and have enacted these REACH codes. So a REACH code alters the state building code, allowing local public utilities and entities to mandate all electric buildings and banning the natural sale of gas for residential and commercial buildings and remodels. So far, there are 76 cities and counties in California that have enacted these building REACH codes. And here's some cities that are listed. Most of them are in the Bay Area. However, that's moving. Southern California is moving up, and pretty soon the state's going to get there. So new homes and buildings that were constructed in 2023 had to have had electric supply panels and circuitry to support all electric appliances. And to get for the building code. So basically, existing homes that are building, if you're doing a remodel, those buildings, they haven't figured out, they're going to have to do it as well. But different codes in different cities will decide what level of a remodel you'll have to meet that new mandate on. So these are just some examples of the building codes. This is taken right out of Santa Monica. New pool construction, heated by electric heat pump, water heater, or solar thermal. And in the pool industry, we know solar thermal cannot get a spa to 104. Like Eric touched on, we can get to 104 degrees. They have it for commercial as well. And then Northern California, they have the same thing, residential and commercial. And I kind of blew up a little bit where it says no natural gas or propane plumbing installed, and including heating of indoor and outdoor pools and spas. So it's there, and it's a matter of whoever embraces it and just getting on board with it. That's where it's going to happen. So for the swimming pool industry and spa, that means there'll be more significant changes in decarbonization. So more homes and pools with pools and spas will be prohibited from using natural gas. And with alcohol heat pumps, we can continue to heat pools and spas, especially as regulations start going into effect in many cities. So I could get a little bit more technical now. Dylan kind of described a little bit, but I think I may have a little bit more on that. So how a heat pump works, heat pump, it takes free heat from the outside air and transfer it to the pool water. Heat pump doesn't burn energy to create heat. It only uses a small amount of energy to transfer the free heat from the air into the pool. A heat pump is essentially a mechanical collector of solar energy, and many of our heat pumps can also cool the pool as well. And we talk in the heat pump industry, we talk about COP. So this process can result as much as a 710% efficiency, and that would be a COP. So a COP is how it's all measured. That describes the efficiency of a heat pump. So how it works is a heat pump transfers the free heat from the pool. So we have a fan that draws air in through the evaporative coil. 85% of the heat transfer goes through right there. That's collected there. And as the fan draws it through, the cool water goes in and the warm water comes out. And here's a little chart, kind of like what Dylan had, but a little bit more detail. So we have liquid refrigerant, a cool liquid refrigerant inside. It goes through the evaporative coil, which turns it into a warm vapor. And we have to be able to compress that. So as turning into a warm vapor, we can compress the vapor, goes through the compressor, it compresses it, goes through, it turns it into a hot vapor refrigerant. That goes into our ThermoLink heat exchanger. And what happens is the water then will flow in over the top of that and will transfer the heat from there and come back out and cools the liquid refrigerant down, and the cycle keeps working on and on. In the reversing mode, in the chill mode, all it does is we just spin that in reverse, and then it just decompresses it instead of compressing it. So here's our ThermoLink heat exchanger. It is a canister designed. It's so basically we have titanium tubes on the inside. As the water flows in, it flows out. We can actually run with this system. We can run as low as 1,560 RPMs, which will actually increase efficiency of your variable speed pool pump. So you don't have to run your pump at a higher speed, which will cut the cost down of your total electricity usage. So again, other companies are using a tube-in-tube where it pushes the water through. You have to push it through at a higher speed. With our heat exchanger, we don't have to do that. We can run at a low RPM and keep the same flow rate going. So even though people have a lower purchase price on their heat, operating cost is a little higher because you spend more money on electricity. Here's a little chart I put it together on, kind of shows the curve of the variable speed pool pump. So if you have to run it at a higher speed, you're going to be using a lot more input power. So we really want to keep it down at a lower RPM so we can run longer with less cost. So we have a product line. We have been started manufacturing swimming pool heat pumps since 1981. AquaCal has manufactured over 375,000 swimming pool heat pumps worldwide. We do have distribution worldwide, and we have a number of different product lines. We have our HeatWave Super Quiet. It has a quiet footprint of like 55 decibels at 10 feet. We have our straight heat only heat pumps, a little bit not so much quiet. Excuse me. We have our Tropicool, which are straight chiller heat pumps. And then we have our GBB line. Those are our commercial units that Dylan referred to. In the Bay Area, we just recently put them in Facebook Center up in Menlo Park. And we have 5 units in at the community center. We have 3 for one pool and 2 for another. And so we have those in operation in California, along with other areas throughout the United States. And then we have a couple water source units, and these are our geothermal units, where the units on top, those are air to water transfer. These are water to water transfer. So the bottom is we use a geothermal loop. We can take well water. We can take a geothermal loop in the ground. We have our SunPower unit. So if people want to be able to heat their spa and not necessarily want to keep their pool hot year round, or they may have their pool on a thermal system or a gas system, but they want their pool spa hot, we can actually extract the heat from the pool water, transfer that to spa water, and then dump the cooler water right back into the swimming pool. So as long as you get 48-degree water source, I can get 104-degree water. We can extract the heat right out of that water. It's pretty cool. So on our 166, it does have our icebreaker technology, and it extends the swim season longer than most other pumps on the market. We can run in low ambient temperatures with this unit, all the way down to 28 degrees. So we also can run at a lower speed, and we take advantage of our patented thermal link heat exchanger. Again, it's not the pump runtime, the humidity. We have to be able to run it longer. So heat pumps in general, when they get to like 50, 55-degree air temperature, they're going to ice up and they're going to shut down. What ours does, ours actually has an automatic defrost built into it. It will sense any ice trying to build up on it. We'll automatically go into a defrost mode. We'll spin it in reverse automatically. We'll melt any ice, hence the icebreaker. We'll spin it in reverse. We'll actually then continue to heat. So we can actually heat longer, more efficiently than any other in the market right now. So we can continue to heat even in the freezing temperatures. And then we have our units that will actually heat or cool, or heat and cool. And our units will cool down to 40-degree water temperature. So we can actually use one unit for a cold plunge, get down to 40 or up to 104 degrees. So we have actually, where we had this top before, we now changed to a new top design. It's a little bit more efficient in cooling mode. It's able to run, it is adaptable to other units. We do have our traditional heat pump. And with this unit, we do have an icebreaker technology with this unit as well. It's just not as quiet. And then we have our line of chillers, and these are chill only units. So a lot of people want the cold plunge right now. And we have 3 different size models available. These are straight chillers. Some people may not want their pool hot, but in the desert region, we're finding a lot of these in Texas. We're using a lot of these just to cool the water down because the water just gets too hot. And we can actually cool a large body of water down about 12 degrees with one of our large models. And then we have our geothermal units, which are our water source units. And so we have our water source and our SunPower unit. I touched on that a little bit before. So here's our big GBB commercial unit. This is a 500,000 BTU heat pump. And we can actually link our heat pumps. We can actually put 17 together onto one control panel. So if you have a bunch of units together, we can actually tie all of them in together so you can run everything off of one control panel. And all of our heat pumps right now, I know Eric said that they have automation built in. We actually have automation built into our heat pump as well. And so we can do that through our smart microprocessor controller. And we can actually control, we have adaptable where we can control up to 4 actuators and 6 relays. So we can control ponds and lights and filters and anything else that they need to control through our automation system. We have a dial indicator for our heat only units. Most of these will hook to automation, but it's usually just on off. We can adjust temperature up and down, but that's about it. And then we can contact with our automation. We can control with Pentair, Hayward, Jandy, or we have our own automation, our PoolSync Wi-Fi controller, which is basically an antenna that goes, it's adaptable to our units, and it comes with an app that you turn on and go from there. So Dylan talked about a sizing program. So at AquaCal, we actually came up, I wanted to spend a little bit more time on this. We actually came up with a sizing program, and we're constantly working on our sizing program. It's on our website. Go to aquacal.com. You'll see when it comes up, you'll see the sizing saving estimator. You simply click on that, and you can help choose the correct heat pump size, because that was a question that was asked, how do you size the right heat pump? Well, this unit will do that for you. We can also go between gas and cost between gas and electric. We can show savings in multiple different ways with either a blanket or a cover on the pool, a liquid blanket, or uncovered. Again, that's our website. If you want to go right to the sizing program, but if you go to our website, you can click on the link, it'll take you through there. So getting into that, first thing you're going to see, it's going to come in. We have different way we can heat it. We have cooling application, or we have a spa application. I'm going to focus on the heating application right now. You would simply put in your average depth. For this example, I used a 15 by 30, automatically calculated by 13,500 gallon pool. If you don't know that, you know your gallons, you put the gallons in as well. You would pick as an air source, a geothermal unit. And then from there, you would also pick your location. We are collecting data from about 20 years of history for our zip codes. It will get your current location if you click on that, or you just put in a zip code and we'll pull it up. Windy or coastal applications, you click on 60 or 50 hertz. Everything in US is 60 hertz. So again, we have this because we do all over the world. You put in your electric kilowatt hour rate, 25 cents in LA right now, and it's a little low, but that's your average cost of electricity. We do have time of use and other things, but if you're in with solar electric, then you can actually, you know what your rate is. And let's say you're only paying 5 cents a kilowatt hour or 10 cents, you would put that in right there. You then can click on your desired temperature you want. You can pick the months you want to do, and your desired temperature, you can slide that across. I picked all year at 80 degrees, just for the example. It came up with a unit, a recommended unit, and from there you can pick the unit you want. You don't have to pick that unit, but we picked that unit right there. It automatically do it. You hit generate cost estimate, and it will tell you that with the heat pump at that electric rate, at that time of year, all year round, at that water temperature, we can keep your pool heated with a cover or blanket for about $1,483 a year, opposed to no blanket at $3,700 a year. Take it one step further, we can actually compare it now to gas. You put your gas rate in, and then you can put all your data in here, and you can hit generate cost gas estimate. It will then show you that based off the rates that we put in, a covered pool, let's go with an uncovered pool, because a lot of people don't have pool covers, $3,700 a year to keep your pool at 80 degrees, opposed to with the gas heater over 12,000. That's 70% savings right there. So we can take it one step further on that. We can print out a whole estimate. We'll know exactly how much every month is going to go. Look at your 10-year savings. And then if you're using this for any of your customers, you can use this as a sales tool, or just look at it and you can say, look, over 10 years, you're going to be saving, you look at your costs over 10 years, opposed gas to heat pump. you're saving almost $100,000. You know, who's going to say they don't want to save $100,000 over 10 years? So come on. And then we can actually take it and print out a whole thing with it, and we can actually get it down to a PDF where you have that for your files, and you can go back and refer to it anytime. We have things in there where we can do a disclaimer. If you look on the bottom, it's based off water temp and pool at 80 degrees year round. So basically, to wrap things up, the U.S. market potential for heat pumps for pool and spa heating. Well, as California leads the way into electrification and decarbonization world, other states are following suit and starting a bold path to cleaner energy, which will result, which will reduce the carbon footprint nationwide. This will result in more demand for pool and spa heating without the reliance of natural gas. And AquaCal, we're leading the way. So if anybody has any questions or anything, there is the website. We have all the information there. There's also my contact information. Feel free to send me an email. If you need to call me, but there's my email. That'd be great. Thank you.
Thank you, Don, for that wonderful presentation and for explaining the concept on choosing the right size. Moving forward, we have a final presentation from Morgan Heater. I know we are running a little behind from our scheduled time, so I request everyone that we'll be just extending 10 to 15 minutes more. We'll wrap up the final presentation and we'll take up the Q&A for the panel discussion. So Morgan will be talking about some of the insights from the retrofit feasibility study. So over to you, Morgan.
Hey, everybody, see my presentation?
Yes.
Okay, there we go. I'm Morgan Heater, Senior Mechanical Engineer with Ecotope in Seattle. Ecotope is a engineering and research firm. We focus on bringing new technology to the market with emerging technology research and doing high performance building design. And also we have quite a bit of code policy work that we do too. Over the last 40 years or so, we've come up with some kind of basic tenets that we use when we're approaching all of our projects. Right now, we're definitely focusing on electrifying buildings, getting carbon out of the built environment. And we firmly believe that the most efficient HVAC equipment, pool heating equipment, whatever end use you're talking about is equipment that is off. And as we're doing this work, we're going to need to figure out ways to integrate the end uses with the grid. So when we're using power is really important. So retrofit process. I personally have been working for the last several years developing electrification, decarbonization plans with kind of large municipal clients like the city of Seattle. And they have a bunch of large community centers with attached pool facilities, natatoriums. And most of these are indoor pools. So I'm going to talk a little bit about the process to go through and come up with a heat pump retrofit plan for a facility like that and in a relatively heating dominated climate. So what we always wanted to do for the first step is see if there's any sort of base inefficiencies in the way the pool is being currently operated. For instance, if people aren't using pool covers or if the ventilation system is set up incorrectly. So identifying things like that right off the bat is a big way that you can reduce the load that your heat pumps are going to see and also save energy and cost for your pool heating equipment. The next step that we think is really important is to do some metering for existing pools. A lot of the time, if you try to replace the existing gas equipment with a 1-to-1 capacity and heat pumps, you're going to have a drastically oversized system, and it's going to be extremely expensive, and it'll kill your project. So getting some metering equipment installed, metering the loads on the pool, metering the space heating loads, and then also the domestic hot water loads is a really good first step. Next, after you know what your real world loads are, and you've taken out your savings from your load reduction strategies, you can reach out to equipment manufacturers and figure out what equipment you're going to use to meet your pool heating loads. And then you can share that equipment with other team members, electrical and structural engineers, and figure out how you're going to fit that equipment into the existing facility. A lot of the time, especially for large commercial projects, the physical size of the equipment is pretty large, the heat pump size compared to the boilers. And so finding a space to locate them can be pretty challenging. And then also the existing electrical infrastructure can be relatively small if it was designed around a gas building. So you need to figure out what the implications are for both those infrastructure systems. And then the last couple things that are usually good to do is figure out what your utility savings are going to be, to help do some life cycle costing analysis, and then reach out and coordinate with utilities and other entities to see if there's availability for grants and incentives to help offset the price of the upgrade. So once you've gone through that retrofit process and you have a project all planned out and the client's on board, then you need to get into the actual detailed design of the system. And that's when you bring in your mechanical, electrical, structural engineers, and you do a full design process. Some of the manufacturers have equipment sizing tools. Ectope also built a heat pump sizing tool for indoor and outdoor pools, using some of the ASHRAE information. But again, I think in particular, if you're looking at a retrofit process, getting some metering done is really key to help identify all the sizing for the different end uses. And then once your design is all done and you've actually got your contracting team on board and you've installed the equipment, it's really important to make sure you have a robust commissioning process where you're making sure that everything is installed the way that it was intended to be installed, and then operating the way it was intended to operate. In a perfect world, there's some equipment installed in the and prove that your system's working the way it should, and also can verify savings for any utility or other kind of incentives. And then the final benefit to that is that you can check back in on your system every so often with the client to make sure it's still working the way it was designed to originally. So we've talked a lot about pool heating, but in indoor pools, there are more than one end use. So pool heating is obviously a significant end use. Space heating actually can be equal or greater than pool heating, depending on how your system is installed and controlled. If you have a client that requires really high ventilation rates, for instance, which a lot of the Seattle community centers are really nervous about indoor air quality, so they want a lot of outside air. Space heating is actually roughly equal to the pool heating energy use, which is means that your pool heating heat pump system should also probably be set up to do space heating, or you need to have another space heating heat pump system if you want to electrify the building. And then domestic hot water is also a pretty big end use that's good for heat pumps in pools. Dehumidification for indoor pools can also be a really big end use. Basically taking the humidity out of the air to protect the building structure and maintain healthy indoor air quality and reduce the chance for mold growth. Can use quite a bit of energy, but it's also a really big opportunity for heat recovery to the pool, which can offset your pool heating load. And so we encourage everyone to consider that. And then, especially for indoor pools, obviously, ventilation for indoor air quality can be a pretty big heating load in cold climates. So applying heat recovery to that's really important. This is a little bit of metering data from the Meadowbrook pool here in Seattle. What you can see from this is that although the peak load during the day is pretty high once the pool covers are on and the system sets back, the gas boilers actually aren't running to heat the pool at night, and so the temperature just drifts. So what this means is that although the boilers are providing roughly 26 tons, you could potentially size your heat pump smaller than that, your heat pump system smaller than that, and run it for more hours of the day, and let the pool heat be kind of more uniformly applied, which would save installation costs, electrical impacts, and also space impacts. So that's one thing to consider, and a good benefit for doing some metering. The other thing to note is that pools are a really big heat sink. And so if you have a area like California where you're starting to run into issues where there's excess renewable energy at certain parts of the day, and you're having problems with your the utility needing to actually pay people to get rid of that extra electricity, and then not enough use at other times of the day, pool heating can be a really good way to dump excess electricity from the grid. So integrating your pool heating system with utility demand control is a pretty good strategy for future-proofing your building. And then in addition, you can offset that pool heating load with dehumidification, heat recovery, like I mentioned earlier. So to talk a little bit more about dehumidification, ideally what we've seen is that a lot of the time heat pump systems kind of run into issues when there's an all-in-one heat pump system that's trying to provide dehumidification, space heat, and ventilation all for the natatorium with one system. So we would encourage people to separate those systems, have a separate system for dehumidification that's controlled just to maintain the humidity in the pool, and then dumps all the heat back into the pool. That allows you to also have a separate system that's controlled to maintain good indoor air quality independently. And then you can combine that system perhaps with space heat, or have a third system to do that. Also, the water temperatures are different, so it makes it a lot easier to control if you can separate those systems from each other. And then finally, if you have a natatorium where there's a problem with air balance, you can use your dehumidification system to increase the exhaust in the pool and reduce your exfiltration from the pool into the pool structure and help protect your building. So domestic hot water systems, they're a very different temperature than pools. You know, you want your domestic hot water to be at least 120 degrees usually when you're delivering it. and it gets mixed down cooler. But then because there's often kind of vulnerable populations in pools, elderly and young children, you should probably be designing with some awareness of Legionella concerns. So you probably want to be designing around 140 degrees. And so again, a lot of times what we see is that currently boilers are providing very hot water, and then it's being mixed down to serve all these different loads. You have one giant system, but that doesn't really work very well for heat pumps. So we want to separate domestic hot water from the pool heating, humidification, etc. Give it its own system, optimized for the temperatures it needs. Ecotope does have a custom domestic hot water heat pump sizing tool on our website, where you can take some metered data, put it into a curve, and then it'll help you size your heat pumps for domestic hot water and your storage for optimizing that system. Here's a little metering data from another pool in Seattle. This is the Rainier Beach Community Center. This is about weeks worth of data, a couple weeks worth of data, and you can see there's peaky flows that get up to roughly 25, 26 GPM at maximum, but very, very briefly. Generally, the domestic hot water use is quite a bit lower, less than 10 GPM. That's because people are coming in and out of the pool building, taking showers briefly before swimming, taking showers briefly after swimming, but there's usually not people taking showers continuously. The kind of peak use that we saw for our metering period for the Rainier Beach pool was about 1,700 gallons a day. So it's quite a bit of hot water, but it varies a lot. So storage, again, is key for reducing your heat pump sizing. CO2 heat pumps are definitely the best solution for cold climates because they operate down at really low temperatures with still relatively high efficiencies, and they can deliver hot water, 150, 140 degree water to deal with Legionella concerns. And then again, domestic hot water is a great resource for integrating with the grid for load shedding and demand reduction. And that's the end of my presentation.
Thank you so much, Morgan. And thank you for touching upon the topic of CO2 for cold climates, because we did have a question of that in the Q&A. And as I see that we have covered most of the Q&A session in the chat itself, and we are a little over our scheduled time. So I would like to thank all the panelists. Could you please all come on camera? Thank you, Eric. Thank you, Dylan, Dawn, Sean, and Morgan. Thank you so much for joining us today and for this wonderful, insightful presentation and valuable notes that you have shared. We will follow up with the recording and the slides with all the registered participants shortly after the webinar. Most probably you'll get this tomorrow in mail. And for all the questions, if some of them are left unanswered, we will definitely follow up with them. We'll forward it to the panelists and they'll get back to you over the email. So thank you once again. I wish you all a great rest of your day. Thank you for joining us.
Thank you. We're happy to be a part.
Thank you.
Thank you.
Thank you, everyone.